Hi folks, welcome to part 5 of the 7.1 videos. So if you've made it this far, good job. You're taking a look at more examples of verifying identity, all right? All right, so we're gonna start here with our more complicated side, and we're gonna show you another trick that is pretty common in simplifying these identities, okay? So what we're going to do, I see two fractions, and what I want to do is combine them into a single fraction. And in order to do that, I really need to have a common denominator. So I'm going to go ahead and copy down the problem as it is. And then before I write that equal sign, I'm going to multiply by, we're going to use that fancy one trick again. Okay, we're going to do that fancy one trick that we did from the previous video. Now, the fancy one over here is going to be 1 plus cosine theta. And the fancy one over here is actually going to be 1 minus cosine theta. And the reason we're doing this is because then we get these denominators to be the same. And yes, it is a lot of writing, but we do have to write that other side. You're welcome to not write the other side so long as you know that's not getting full credit. That is fully your choice, but if you would like the full credit, then you will write both sides, okay? All right, so now let's do a little bit of algebra, all right? And before I do that, I'm actually gonna make sure I see all my parentheses here. All right, so I know that I'm foiling a bunch of stuff. All right, what do we get for the first fraction? 1 plus 2 cosine theta plus cosine squared theta. All right. What do I get for the numerator? I get 1 minus cosine squared theta. Let's talk about that second fraction. 1 minus 2 cosine theta plus cosine squared theta. And then in the denominator, 1 minus cosine squared theta, and that equals 4 cotangent theta cosecant theta. And all we've done here is a bunch of FOIL. All right, so we could also call that algebra. We don't have to write FOIL, but sometimes I just like to be specific so we're not just mindlessly writing algebra, but we actually know what we're doing here. Now we're going to go ahead and combine our fractions, but we are combining them with subtraction. And so one thing we really need to be careful of, we are subtracting this whole thing. And so it's really important that we distribute that minus sign all the way through, okay? So our new fraction will have the numerator 1 plus 2 cosine theta plus cosine squared theta minus 1 plus 2 cosine theta minus cosine squared theta equals 4 cotangent theta cosecant theta. Right, and this, I would say, is more algebra. All right, let's see if anything we can combine. 1 and 1, cosine squared and cosine squared. And then I have 2 cosine plus 2 cosine. And that, my friends, gives me 4 cosine theta over 1 minus, 1 minus cosine squared theta equals 4 cotangent theta cosecant theta. Okay. So what have I done here? I've done more algebra and combined my like terms. And even though it got really messy in that previous step, it got way better in this last one. All right. Now, I'm going to put a purple star next to this one. Okay, because like before, we had said, here's a Pythagorean identity. but we can subtract things from both sides. So like in this case, if I subtract cosine squared, I get sine squared x equals 1 minus cosine squared x. And just like the previous video, everywhere I see 1 minus cosine squared, I can replace it with sine squared. Okay. All right, so I get 4 cosine x over sine squared theta equals 4 cotangent theta cosecant theta. All right. Oops. And this is our Pythagorean theorem. Okay. Now, we are running out of space a little bit, so I'm going to cheat and I'm going to go ahead and shrink all of this just enough to give us more space. All right, but we are almost done here. Okay, I'm actually going to write this as 4 cosine theta over sine theta times sine theta, which I hope will equal what I want it to equal. Okay. But one thing I might notice here, let's choose a different color, oh, better color, is that cosine over sine is cotangent. So I can use the reciprocal identity there. And 4 over sine is really 4 cosecant. Okay, so I have to be clever with the way I group these, but then I'm just going to find that 4 cotangent cosecant is equal to 4 cotangent cosecant. Okay. Now we want to make sure that we've got our annotations here. So we've got our reciprocal and our quotient identities to help us finish that off. Okay. So some of these questions are going to be long and they're going to involve a lot of algebra. All right. But if you ask any student who's taking calculus what the most important thing is, a lot of times they'll tell you it's the algebra. You got to know your algebra. All right. So this is a good chance to practice those skills so that when you get to calculus, you don't feel totally blindsided. Okay. All right. Let's take a look at 15 here. So for 15, I think we'd all agree that this left-hand side looks much messier than the right-hand side. So we're going to work with that side. Now this requires us to FOIL, and this also requires us to FOIL. Now this is so important. I'm actually going to take the time to write out what that squared means, because I can't tell you how many people just say, oh, I'm just going to distribute the square and call it a day. And then I tell them that they're wrong. And they're like, well, why? And I tell them because you have to FOIL these, right? And I think one way you can remind yourself is to go ahead and write it out this way to begin with, right? Now I'm going to do the same thing here. 2 cosine theta minus sine theta. And I'm going to square that. So I'm going to multiply it by itself. Okay. Now, if you always remember to FOIL, you don't need to write this step. But if you forget to FOIL and you don't write this step, I don't feel bad for you. And I don't think you should either. Okay. There are ways that you can prevent yourself from making these mistakes. You choose. All right, let's start our FOILing process. 4 sine squared theta plus 4 sine theta cosine theta plus cosine squared theta plus 4 cosine squared theta minus 4 sine theta cosine theta plus sine squared theta equals 5. All right, so all we've done so far is a lot of algebra. Now, let's see if anything reduces. I've got a 4 sine theta and a negative 4 sine theta, cosine theta, so those go to 0, all right? But I also have 4 sine theta plus 1 sine theta. That gives me 5 sine squared theta, right? And if we're using color coding to our advantage, we've got this and this make this term. Plus, we can do something similar with this one and this one. 5 cosine squared theta equals 5, okay? Now, I noticed that both terms have a 5, so I'm going to go ahead and factor out a 5. 5 parentheses sine squared theta plus cosine squared theta equals 5. Right, so this was some algebra. This was more algebra. I haven't even used any trig yet, but I get to use it now because sine squared theta plus cosine squared theta is 1. Why is it equal to 1? None other than our Pythagorean identity. Okay, so everything in the beginning, algebra, 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 algebra. Not until the very end did we use our identity. All right, so we have to be comfortable with that. We have to say, all right, let me try a bunch of this algebra, see what happens. Okay. All right, last example. Let's take a look at this. Okay, so I've got sine squared theta over cosine equals secant theta minus cosine. So here's what I'm going to do. I'm actually going to start with a Pythagorean identity this time. And I notice that I have a sine squared in the top. And I can replace that with 1 minus cosine squared because of our Pythagorean identity. Okay, so I want to label this right here. This is our Pythagorean identity. All right, now one really handy algebra trick, all right, and again, we'll put this off to the side, is that if I had 1 plus x over 2, I could actually write that as 1/2 plus x over 2, okay? Or if I had x squared plus 3x minus 4 over 5, I could actually write that as 3 separate fractions. Okay? So why is this useful? Well, over here, I have 2 terms in the numerator. So I'm going to split this into 2 separate fractions. 1 over cosine theta minus cosine squared theta over cosine theta. And I hope that that equals secant theta minus cosine theta. All right, so we split our fractions here. Well, 1 over cosine, that's secant theta. I know that from the reciprocal function, the reciprocal identity. And cosine squared over cosine, well, when I do a little algebra, just gives me cosine theta. All right, so there we have it, folks. Not too bad on this last one. I know some of the other 2 were a little bit juicy, but these 2 weren't so bad, or this last one wasn't so bad, okay? So annotations, show every single step, make sure that you are able to justify your reasoning on things and write both sides. All of that will get you full credit, all right? Thanks for stopping by.